welcome to today's webinar, Cloud Data Migration, 6 Strategies for Getting Data into AWS. Our presenter today is Guy Faber. Guy is a Business Development Manager for AWS Storage Services. His focus is to help customers optimize their data storage infrastructure by leveraging AWS Cloud Storage Services, collecting customer feedback for S3 and Glacier product development, and leveraging partners to complement AWS storage solutions. Prior to AWS, Guy filled several sales and systems engineering roles with leading data storage and networking manufacturers. Today with us, we also have Mark Stelzer, Principal Product Manager for EC2 Networking, Eric Durant, Business Development Manager at AWS, Roy Ben-Alta, Business Development Manager, and Drew Mayer, Senior Product Marketing Manager for Storage Services. They will engage with you and answer your questions throughout today's presentation while Guy presents. Guy, welcome. I now pass the floor to you.
Hi everyone, and thanks for joining the webinar today. We're going to discuss 6 effective methods to move data into the AWS cloud and discuss which use cases each one is best suited for. The audience is expected to have some basic knowledge of core AWS principles and services such as VPC, Virtual Private Cloud, and S3, Simple Storage Service. So you're a customer that's excited about all the benefits and capabilities that AWS has to offer, but how do you get existing data that was generated in your on-prem data centers into AWS? Some of these scenarios include, and you can kind of see them on the slide here, moving some or all of your applications to run in AWS to benefit from elasticity, deploying a disaster recovery replica on AWS instead of an additional data center, and leveraging the high durability and superior economics of S3 and Glacier for cloud backup and archive, or simply to take advantage of the wealth of analytics services that we offer, such as Elastic MapReduce and Redshift. So today we're focusing on data ingest options, how to get data into the cloud, but I wanted to give you a quick taste on the different storage services we provide once you transfer the data over. This is where you're going to persist your data. So data comes in all shapes and sizes with different requirements for performance, cost, and the different access interfaces. AWS provides several services that address those different needs, with S3 being a globally accessible and highly scalable object storage service. Glacier has a similar object architecture but caters for deep archives and long-term backup. EBS, or Elastic Block Store, is a high-performance block storage dedicated to EC2, analogous somewhat to a SAN, a storage area network. And EFS, Elastic File Store, is a high-performance NFS-based file system dedicated to EC2, which again is somewhat analogous to a NAS. What's common to all these services is they all run on AWS, which means there's no need for you to put up any upfront investment or commitment. You pay only for what you use, and you don't have to perform any complex or risky capacity planning, which is pretty common with traditional storage systems. They're all easy to use and designed for very high levels of availability and durability, allowing you to reduce time to market by easily provisioning petabytes of capacity in minutes, without ever worrying about running out of space or hitting performance bottlenecks. So here's what we're going to look at today in detail. We won't have time to dive deep into any of these options and services, but my goal is to give you a good understanding of each one, when it should be used, and where to go for additional information. So we divide data transfer services into 2 categories. Transport tools, you can see them on the left, that enhance or augment internet connectivity between your location and our AWS regions. And the second category is tools that simplify the way you interface with our object storage services across the previously mentioned connectivity services. With connectivity, the basic one is the internet. To augment that, we'll also introduce a service called Direct Connect, which is your tool for directly peering with the AWS backbone. We'll talk about a service called import-export disk, which allows you to send data with your own disk drives for import into AWS. And Snowball, a petabyte scale service where we send you our own ruggedized devices. On the interface side, you can always use our service APIs or CLI commands to copy data over, but in addition to that, we offer the Storage Gateway, a virtual machine-based gateway that simplifies backup and archive. We have partner solutions around backup, archive, and data migration. And then finally, we're going to talk about Kinesis Firehose, which is an optimal solution for collecting, aggregating, and ingesting log and device data into AWS for storage and real-time analysis. So let's start with Direct Connect. Direct Connect provides you with a dedicated pipe into AWS, and we'll talk over the next few slides on how that works. It can either extend your on-prem network into your own Amazon VPC, Virtual Private Cloud, or give you direct access to regional services such as S3. Same as with sending data over the internet, transferring data into AWS is free. But we charge to cover our networking costs when you transfer data out. And it's usually at 2 or 3 cents per gig, which is significantly cheaper than what we charge data transfer out over the internet. So there's a break-even point where Direct Connect becomes cheaper compared to using the internet for data transfer out charges. Because you have a dedicated pipe, the main advantage you get from Direct Connect is you get consistent throughput and low latency, low consistent latency. You're not sharing it with anybody else. Each AWS region is associated with at least one Direct Connect location. These locations are large co-location facilities such as Equinix or CoreSite with large concentrations of customers. You can deploy multiples of 1 and 10 gig E connections for bandwidth aggregation and redundancy. And you can also use the internet to back up your Direct Connect links. So you can use these things in combination. Finally, we use BGP, Border Gateway Protocol, to peer with AWS over 802.1q VLANs in the dedicated link. So how does it look like from a physical perspective? We extend private fiber from our AWS regions to the Direct Connect locations associated with a region. And we set up a patch panel in a meeting room in that co-location. If you already have a footprint in those locations, it's an easy cross-connect into Direct Connect. If not, you can work with one of our telco partners to establish last-mile connectivity. We recommend redundant fiber connections or at least an internet-based VPN connection as backup. There are two main deployment models here. The first depicted in the diagram in this slide is for a customer that already has infrastructure deployed at the co-location, such as, again, Equinix or CoreSite, where we offer Direct Connect connectivity. Here, you can place your router in the co-location, and the colo provider will cross-connect it to the AWS backbone. What you buy is the cross-connect service from the colo provider, and you buy from us access to gig or 10 gig ports, and then get dedicated connectivity from your network to ours. Alternatively, a Direct Connect partner such as AT&T or Level 3 can arrange a cross-connect on your behalf to their network equipment at the facility. They can then transport it using one of the previously mentioned services to your location and router where you will still be running BGP over VLANs. So here your router, instead of being located in the colo, it's located in your own premises, but you still use BGP to publish and exchange network route information. This is a good choice if you don't have a presence in any of our supported co-locations. And also some of our partners can provide more granular fractional gig services with this alternative. So we have more than 20 Direct Connect locations all over the world at this time, and we keep expanding the service based on customer feedback and according to our region expansion plans. If you look at the list, you can see that we have a Direct Connect location for a recently launched region in South Korea that was launched in January. So we're always going to launch direct connect locations with new regions that we put into general availability. You can view the complete list of locations, associated regions, and partners available globally on our website, which brings us to the next slide, which has resources for additional information. YouTube has many valuable recordings from reInvent, our annual customer event. I included here both the link to a deep dive recording and the slides on SlideShare, as well as a link to our product page. On YouTube, you can simply use the provided links. We're going to send you these slides a few days after the session, or you can search for the presentation and other great content under the AWS reInvent playlists. The Direct Connect product page includes service details, pricing, and as I mentioned, a list of locations and partners. But sometimes using Direct Connect or Internet is either not a possibility, it could be too expensive, or it's just not fast enough to transfer a large amount of data in time for our business purposes. We also see situations where a customer is looking to do a one-time or infrequent data transfers, and for those, it just doesn't make sense to commit a large internet or dedicated pipe. For these reasons, we offer two offline disk-based import and export services, which you guessed it, are called import and export. So the original import-export service is now several years old, and we recently renamed it Import-Export Disk. It accelerates moving large amounts of data in and out of AWS using customer-owned portable storage devices for transport. AWS Import-Export enables you to move data in and out of AWS S3 buckets, Amazon Glacier, and Amazon EBS. Portable devices can be shipped to Amazon, and then the data is processed and securely transferred to an AWS data center, where the device is then attached to an AWS import-export station. Your data load typically begins the next day after your storage device arrives at AWS, and after the data export or import is completed, we send you back your storage device. When you choose your device, and I'm going to give you a few links in a few minutes here to show you what devices are supported, make sure it has either a USB or eSATA interface. Those are the ones we support. With individual disks supported up to 6 terabytes and RAID arrays up to 16 terabytes. For large data sets, import-export can be significantly faster than internet transfer and more cost-effective than upgrading your connectivity, especially for one-time or infrequent data migration. Import-export Snowball is a new service we introduced late last year at reInvent. It improves upon import-export disk in several ways based on customer feedback that we received. So Snowball is a new import-export offering that provides a petabyte scale data transfer service that uses Amazon-provided storage devices for transport. So if with disk, customers purchase their own portable storage devices and use them to ship their data, with the launch of Snowballs, customers can instead leverage highly secure, shippable, ruggedized, Amazon-owned, network-attached storage devices, and they're called Snowballs. So they got a few compelling advantages. First, it's very scalable. Once received and set up, you can copy up to 50 terabytes of data from your on-prem file systems to the Snowball using the Snowball client software over the integrated 10 gig and 1 gig network interfaces. And you can use multiple of these Snowballs in parallel to support large migration jobs. It is highly secure. So prior to being transferred to the Snowball, all data is encrypted by 256-bit encryption by the client, and the device is also equipped with tamper-resistant seals and includes a built-in trusted platform module that's designed to detect any unauthorized modifications to the hardware, firmware, or software. From a durability, physical durability perspective, please don't drop it, but it can sustain 8.5 Gs of pressure. It's dust-proof, and it's water-resistant, not waterproof. So it can sustain some rain and some dust while it's sitting on the dock, but again, please don't drop this into water because it's not waterproof. It's shippable. which means you don't need to deal with the hassle of packing and unpacking it. You can just basically ship it as is. And then what's really cool is it automatically displays the right shipping information on the embedded Kindle-based e-ink display that you can see in the photos. When customers finish transferring data to the device, they simply ship it back to AWS facility, where the data is ingested at high speed into Amazon S3. And I have a slide here that will show you and walk you through the entire process. And a big part of the innovation here is not just the physical design of the device, it's also how simple the process is and how it's being managed. The Snowball service is completely driven by the AWS console, like our other services. From the console, you can access the Snowball service under the AWS Import-Export Snowball link. Once there, all you need to do is create a data transfer job. You need to specify the S3 buckets you want to use, you want to migrate the data into. You specify the KMS, Key Management Service, encryption keys that you want to use to encrypt the data, and then your location, the location you want the device to be shipped over to. Once you receive the device, you'll need to connect it to power and to the network and provide an IP address either manually or via DHCP. From there, data is copied to the Snowball via the client software, which is a command line tool loaded on a host in your environment. The client then encrypts all the data before he transfers it to the Snowball, so it only lands encrypted. And once the data transfer is complete, you simply power down the device and return, the return shipping information will update on the e-ink display automatically. Once the device is returned to Amazon, we'll complete the data transfer from the Snowball to the specified S3 buckets on your behalf. And during the entire process, you'll be able to be notified during each step through the console, through Amazon's simple notification server, or just get text messages on your phone. And after the process is fully complete, Amazon will perform a secure data erasure process before sending this over to the next customer. So you can be assured that none of your data still exists on the device. So that probably brings the question of how fast can I transfer data with the Snowball? How fast can I throw the Snowball? So let's compare using the internet to 5 Snowball units being used in parallel. With 5 of these guys, you can transfer 250 terabytes, a pretty respectable amount of data, in less than a week. In comparison, if you use a full GigE link at 50% capacity, because we still want to use it for our day-to-day operations, we're talking 47 days. Simple math says that if we look at the 10 GigE link, we divide that by 10, it's going to be 4.7 days, which is pretty much in the same ballpark as what we estimated for Snowball, but at a fraction of the cost of setting up a dedicated link, especially if we're going to use it for a one-time migration. Also, remember that you can use Snowball in parallel to using the internet and direct connect links. So you can use Snowball, for example, to seed a dataset baseline and then use direct connect of the internet for the ongoing transfers after that. So I'm sure by now you're having a few ideas on how you're going to be able to use this service, but I want to walk you through some of the main use cases that we heard customers talk to us about. So the first one is cloud migration. If you have a large amounts of data that you want to migrate into AWS as part of an application server, file server, database, or backup and archive migration, AWS Snowball is often much faster, more cost-effective than transferring the data over the internet. Disaster recovery is the second one. In the event that you want to quickly retrieve a large amount of data stored in S3, Snowball appliances can help retrieve the data much quicker than high bandwidth internet or tape, but you can also use that to augment those mechanisms. It's important to note that Snowball currently does not support export, but it will in the near future. So keep an eye out for that. Next one is data center decommission. There are many steps involved in decommissioning a data center to ensure that valuable data is not lost. Snowball can help ensure that your data is securely and cost-effectively transferred to AWS during this process. And then the final one is content distribution. You can use AWS Snowball appliances if you regularly receive or need to share large amounts of data with customers or business associates. Appliances can be sent directly from AWS to your client or partner location, and that also includes locations where there's limited or no internet connectivity. I've heard customers talk about mines in the Congo, off-site filming locations, and even boats in the ocean. Of course, you can also upload your own content using Snowball appliances and then share it with partners once it's stored in S3 or any of our other object storage services. So it sounds like Snowball has some significant advantages over import-export disks. And why would I want to use disk? There's several situations where you want to do that. One is you use disk when you wish to use your own devices. That's a significant difference from Snowball, where we ship you our own devices. You use it when the data sets that you need to transfer are fairly small. For example, regular transfers of 2 terabytes a week. You use it when you need to export data out of AWS until Snowball adds that functionality, and also in regions where Snowball is not yet supported. At this time, Snowball is only supported in the US, but we hope to expand it globally in the near future. And lastly, when you need to import directly into EBS or Glacier, something that Snowball doesn't support. In any other situation, Snowball is usually going to be more scalable, cost-effective, and simpler to use than disk. And here again, I want to wrap up the topic with a solid set of resources on import-export, including the reInvent recorded session that introduced Snowball late last year. So moving on to ingest or interface services, let's start with the AWS Storage Gateway. The Storage Gateway expands or replaces your on-premises storage using a software appliance that connects to AWS Storage. It's basically a virtual machine that you download from our website, and then you can drop into an ESX or Hyper-V server. The Storage Gateway works with your existing applications using industry-standard storage protocols, specifically iSCSI, so you don't need to modify your applications or use new data management tools. In Windows, the Storage Gateway can appear as a new drive letter, and in Linux, it can be mounted as a file system. Applications are unaware that they're reading and writing data to and from cloud-backed storage because the Storage Gateway abstracts that and facilitates that the gateway functionality. Data is encrypted before it leaves your data center and while stored in AWS, and the storage is backed by Amazon S3, Glacier, and EBS on the back end. The data you access most frequently is kept on premises, giving you low latency access to data, which is durably stored in the cloud. Like many AWS services, you can grow as needed and you only pay for the storage that you actually use. And there's no need to over-provision or over-purchase storage, as you can just expand or reduce storage without needing to add or remove hardware. It's all virtual. We see customers adopting the Storage Gateway for three main common use cases. The first is backup and archive, which is a natural fit for cost-effective cloud storage. The Storage Gateway can be added to your existing backup process without impacting production operations. The second common use case is disaster recovery. Customers can use the service for secure and durable offsite storage in the event of a disaster. And using the Storage Gateway allows for data recovery to a second data center that you own or into AWS, which is something that is increasingly becoming the DR site for many of our customers. The final use case is when customers are looking to migrate or they need to mirror data sets into AWS. The Storage Gateway simplifies this process of moving or copying data in and out of AWS by providing you that IT-friendly iSCSI interface. So how does the Storage Gateway work? On premises, your application server mounts or connects to the AWS Storage Gateway appliance, again, using iSCSI. And that application server can also be a backup server, for that matter. The appliance, which we often refer to as the gateway, securely connects to the service backend. The connection from the appliance is outbound towards AWS using HTTPS. So it's firewall friendly and it's secure and encrypted. You can route this traffic over the open internet, or you can use a direct connect link if you have one. The backend in turn integrates with Amazon S3, Glacier, and EBS to provide the secure and durable storage functionality. The storage gateway has 3 modes of operation that you can configure: gateway stored and cached volumes, and also a gateway VTL. So let me give you a little bit of detail on each one. The gateway stored volume stores your primary data locally, while asynchronously backing all of that data to AWS. These volumes provide your on-premises applications with low latency access to their entire data sets while providing durable offsite backups on AWS. Gateway cached volumes allow you to utilize Amazon S3 for your primary data, so that becomes your primary data store, while retaining some portion of it locally in a cache for frequently accessed data. So here, instead of mirroring the entire data set, we just cache most recently used data on the gateway. And like I said, both stored and cached volumes leverage the iSCSI block storage protocol for access from your application servers. The gateway VTL, virtual tape library, provides virtual tape storage, and I want to take a deeper look at how the VTL mode works in the next slide. So VTL is ideal for replacing on-premises physical tape infrastructure for backup and archive. So instead of continuing to expand aging virtual tape libraries and having to manage and move around the media, you can simply deploy a virtual library that looks exactly the same as your physical one. So similar to cached volumes, all your data is durably stored in AWS with your frequently accessed data cached on the gateway. In your VTL, you can configure up to 1,500 tapes, each one of them up to 2.5 terabytes in size, which is the LTO6 size, for a total of 150 terabytes per gateway. And of course, you can deploy multiple gateways to scale further than that. For longer term storage, you can eject and archive virtual tapes into what we call a virtual tape shelf, or VTS, which is then backed by Glacier, providing you lower cost long-term storage. And the other nice thing about it, besides the fact that the virtual tape shelf is lower cost, is that there are no limits on the number of tapes you can move to VTS. So it's virtually infinitely scalable. This allows you to build a 3-tier backup architecture: local appliance cache for just super fast retrievals, mounted tapes, which are then backed up by S3, and then ejected tapes on the shelf backed up by Glacier. And you can move around the data between S3 and Glacier by ejecting tapes. The Gateway VTL is integrated with 9 backup applications from Veritas, Dell, Microsoft, and Veeam, and we're working actively to add all the other major vendors out there. You can find a great deep dive session on YouTube that walks you through the detail through all of these storage gateway modes that I mentioned and provides configuration examples. And the product page goes through the use cases for each storage gateway mode of operation, as well as the associated pricing. So let's talk about the AWS partners related to our topic today. AWS has a large ecosystem of partners that allow us to complement and close gaps in our product line. And you can see at a high level a list of our storage and ingest related partners in this slide. I'd like to focus on a few select partners that provide compelling solutions to replace traditional backup recovery and archive environments and provide ease of use, lower cost, and scalability by leveraging S3 infrequent access, and Glacier as cloud storage targets. So I want to spend a minute walking you through 2 cloud backup architecture alternatives and then talk about the partners that enable them. So at the top part of the slide, we have an architecture for backup software cloud connectors. Here, I have my application servers that have the backup software agents installed in them. The backup agents take snapshots of the data and they aggregate them and move them into a media server. And then the media server has a cloud connector that allows it to talk natively with our object storage services over APIs and HTTPS. So in the same way that it natively supports local disk and tape libraries, it also supports cloud services as a target. And CommVault is a great example for native cloud support and a comprehensive backup and archive solution on AWS. They've supported S3 and Glacier as cloud targets for several years now. And last year they added our new storage class, S3 Infrequent Access, that's, as the name implies, is optimized for infrequently accessed data, such as backup and archive. Using CommVault, you can apply your organization's data protection objectives to a policy that leverages on-prem disk for very rapid recoveries, usually your most recent backup set, while offloading all other backup sets into S3 Infrequent Access and Glacier, leveraging superior durability and economics. So just a quick reminder, S3 Infrequent Access is priced in our core regions of US East, US West 2, and Dublin at 1.25 cents per gig per month, and that is for protected data. And Glacier is priced at 0.7 cents per gig per month. So it's very compelling. And CommVault is a frictionless solution that doesn't require any additional hardware or software and can be enabled by simply pointing the software to a bucket in your AWS account and adjusting the tiered data protection policy. CommVault also provides disaster recovery capabilities with their workflow and scheduling features. Another leading backup software vendor that recently added S3 Infrequent Access support is Veritas with NetBackup version 7.7. And I should also mention that Oracle Secure Backup has been supporting S3 standard for a while. So if you're already using any of those tools in your environment, make sure you look at their S3 cloud connectors. And the second approach, let me emphasize it here, involves inserting a gateway, such as the AWS gateway that we just discussed, or a partner one that provides a friendly IT interface and communicates to the AWS object storage services over HTTPS through the internet or direct connect. And if your existing backup software brand or version doesn't support native cloud capabilities yet, or you support a heterogeneous backup environment with multiple products, some of them supporting native connectivity and some not, you can easily insert NetApp's AltaVault series of cloud gateways into your local area network between your backup environment and AWS. The gateway then presents a NAS or file interface, could be NFS or CIFS, which is supported by virtually any major backup software vendor out there, and you can see a list of the major ones on this slide. It also has some valuable additional features like the ability to cache your most recent backup sets locally for rapid restoration, inline deduplication and compression for data reduction, and encryption using your own encryption keys. It comes in both virtual and physical flavors, and it supports using all three AWS object storage classes, S3, S3 Infrequent Access, as well as Glacier. And then another one I'd like to highlight is Ctera with their enterprise file services platform. It's a unique combination of backup software and backup infrastructure, all managed from a single pane of glass. It includes a cost-effective NAS device that you can deploy in remote offices with the ability to protect endpoint applications and devices both on-prem and running on our compute service, EC2. It applies data reduction deduplication techniques to the data, and it stores the data encrypted on S3 Infrequent Access. It also provides a suite of data governance, identity management, and cloud orchestration tools. And another partner that provides a comprehensive endpoint and app server backup solution that you should evaluate is Druva. So finally, I want to talk about the last strategy or tool, Kinesis Firehose. It's a new and exciting service that we introduced late last year at reInvent. So back in November 2013, at reInvent as well, we introduced Amazon Kinesis to the world. And since then, the Amazon Kinesis platform became a core foundation service in AWS that even other AWS services such as CloudWatch leverage internally. Amazon Kinesis is a platform for streaming data on AWS, offering powerful services to make it easy to load and analyze streaming data, and also providing the ability for you to build custom streaming data applications for specialized needs. Web applications, mobile devices, wearables, industrial sensors, and many software applications and services can generate staggering amounts of streaming data, sometimes as much as terabytes per hour, that need to be collected, stored, and processed pretty much continuously. And Amazon Kinesis services enable you to do that simply and at a low cost. The platform consists of Amazon Kinesis Streams. That's how we renamed the original Amazon Kinesis, which is used to build your own custom applications that process and analyze stream data. It contains what I'll focus today with Kinesis Firehose, that gives you an easy way to load volumes of data into S3 and Redshift. Redshift is our cloud-based data warehouse. And finally, Kinesis Analytics, which enables you to easily analyze data streams using standard SQL queries, which has been announced, but it's still not yet available. So Amazon Kinesis Firehose is the easiest way to load streaming data into AWS. It can capture and automatically load streaming data into both S3 and Redshift, and we plan to extend that to additional AWS services. And it's enabling you near real-time analytics with your existing BI tools and dashboards that you're already using today. It's fully managed, service that automatically scales to match the throughput of your data and requires no ongoing administration. So you don't need to shard or reshard. It automatically handles whatever you throw at it. It also has the additional functionality of being able to batch, compress, and encrypt the data before loading it, minimizing the amount of storage used at the destination and increasing your security. You can easily create a Firehose delivery stream from the AWS Management Console. You can configure it with a few clicks and then start sending data to the stream from hundreds or even thousands of data sources to be loaded continuously to AWS, and all of this can just be done in a few minutes. And the service automatically scales to match the data throughput that you need without any intervention. And finally, with Amazon Kinesis Firehose, you only pay for the amount of data that you transmit through the service. There's no minimum fee or setup cost associated with it. So let's look at how customers adopt Kinesis Firehose and utilize Amazon S3 as a data lake for analytics purposes. The primary use case that we see is accelerated ingest, when vast amounts of streaming data needs to be collected, with each one of the records being pretty small. It could be bytes or kilobytes in size, but millions or even billions of these records need to be aggregated into larger files and then persisted or stored in S3. In advertising technology and in marketing, customers are using it for advertising data aggregation, for advanced analytics, for example, optimizing bid scores, or for email campaign management optimization. Clickstream data analytics is another popular one, where we try to analyze user behavior by looking at our data assets. In financial services, customers are running audits and capture massive amounts of real-time financial transactions. And finally, Internet of Things, IoT, is becoming popular as well over the last couple of years, where data is flowing from fitness devices, vehicle sensors, telemetry data, machine data, and more sources. Streaming is a pretty involved and exciting topic, and we only covered a brief overview here of Kinesis Firehose. But the good news is there's an excellent recorded session on the introduction of Firehose on our reInvent channel on YouTube, and the product page holds all the technical and pricing details that you would need to get familiar with the service. So I want to summarize here by saying that AWS provides a variety of transport services and ingest or interface applications to simplify and speed up data migration projects, whether it's a one-time thing or recurring. You can use Direct Connect to provide dedicated bandwidth and consistent latency from your corporate data centers to any AWS region, or in addition to an internet connection. You can use Snowball for one-time or recurring migrations to speed up data transfer or complement internet or a direct connect link. Each Snowball can transport 50 terabytes, and many of them can be used in parallel. Import-export disk is used for the same purpose, but where you'd like to use your own storage devices or in part of the world where Snowball is not yet available. The AWS Storage Gateway provides an inexpensive way to perform backup, archive, and data migration without needing to make significant changes to the existing environment. And there are also additional gateway solutions provided by AWS technology partners that we described, like NetApp, that supports all major backup applications and add value-added features like deduplication. If you have a backup application that supports a native cloud connector, like CommVault or VeritasNet Backup, you can quickly and easily point it at S3 and Glacier and gain improved economics and durability. And then finally, Kinesis Firehose is the simplest, most effective way to collect streaming data and load it into S3 and Redshift for near real-time analysis with existing BI applications that you use today. So with that, I want to thank everyone for your time today. We're going to now take some live questions.
Great. Thank you, Guy, for the great presentation, and Mark, Eric, Roy, and Drew for answering the questions throughout today's presentation. So we will start addressing some of the questions, but apologize in advance that we might not be able to get to everyone's questions. At this point, audience, if you can take a minute to fill out 3 poll questions at the left side of your screen. We have about right now 15 minutes, so please still feel free to continue submitting questions at this time.
Roy, do you mind addressing the question, is there a service in AWS to migrate from OpenStack Swift data to AWS and vice versa? You may want to get closer to the microphone.
It's okay.
We don't have an answer for that at this time, but we might get back to it in a few minutes.
How about the Delphix one? Anybody know anything? But I don't know.
Excuse us, we're just looking at the questions.
Eric, can you answer Tara's question about the interface for Snowball?
The Snowball supports both 1 gigabit and 10 gigabit connectivity. And for 1 gigabit, it's copper only RJ45 Ethernet. For the 10 gigabit connection, there's both a copper twin-X cable provided, as well as SFP plus optical connections.
I'm going to take the following question. What Dell backup applications are supported for data migrations into AWS? So Dell NetVault is supported with the Storage Gateway in specific versions, and you can also use NetApp's AltaVault as a gateway between NetVault and S3.
Yeah, I'll take the question from Les. The question is, do we have to write Lambda functions to connecting Firehose to S3 or Redshift? So Lambda is one option. You can use the AWS SDK using our REST APIs to connect to the delivery stream that you created via Firehose. So Lambda is one option, but it's not mandatory.
Thank you, Roy. I'll take another one here from Ray Duncan. Is the VTL compatible with IBM TSM? So the VTL is not compatible at this time with IBM TSM. The option that you have is using again the NetApp AltaVault Gateway, which is compatible with TSM. So I have a question from Brian McNally here. Is the VPC VPN considered a possible way of getting data into AWS? And the answer is absolutely. You can set up an internet connection directly into a VPC and use a VPN to encrypt the data and move data that way. Today we were trying to give you some additional alternatives to augment internet or VPN-based connectivity with offline using Snowball and online by using direct peering with AWS with Direct Connect.
We got a follow-up on the Firehose. Okay, nonetheless.
Yeah, the follow-up. So the question, do I need to write Lambda to connect Kinesis to Redshift or S3 through Firehose? So Kinesis Firehose is a fully managed service. So if you want to connect to S3, you define the destination bucket, and Kinesis Firehose will take care of streaming all that data, and you can set up the aggregation, the encryption size of the data, and up to what compression function you want to use. And Kinesis Firehose will deliver the data directly to the destination. You won't need to write any Lambda function to do that. The same thing for Redshift. The difference is that it's a two phases approach. First step is you set up the intermediate bucket, and the second phase is that you set up the copy command, and Kinesis Firehose will execute the copy command and reload the data directly to Redshift.
Okay, I have another VTL question here. Is the VTL connection via the internet, or does it have a special setup? So the VTL can work either over the internet or over Direct Connect. Those are the two options. So we need to have connectivity from where the VTL is located in your own data center over to our region, which again means either internet connectivity over VPN or Direct Connect. Eric, can you answer the question from Taras? How information from Snowball will be present at S3? What about limitations at S3? 2 gigabytes per object.
So if I'm understanding the question correctly, essentially what the Snowball client does is it will convert data from a file into an object. And so it will take, for instance, the directory path information associated with that given file, and it will convert it into being a key value as part of that object. And then all of that data then, when it's copied from the Snowball directly into S3, will retain that information, so key value, etc. As far as any of the other constraints, it would be then treated like any other S3 buckets and adhere to the same constraints that S3 has.
Yeah, and another question was which interface is used for connection to Snowball, and the answer is today it supports both 10 gigi and 1 gigi Ethernet links, so you can choose which one you want to use.
Yep.
Am I correct, Eric?
You are correct. And I also see another one here. What would be the easiest way to move data from my data center into Glacier? There's a few options there. It really depends, but you can have either leverage a gateway like a NetApp AltaVault for migrating to Glacier. If you did want to move data kind of as a one-time use or as a batch, Snowball is a good solution for that. The way that that works is you migrate data into S3 first to stage it, and then you can leverage our lifecycle policies in order to have that data automatically migrated from S3 down into Glacier.
Yeah, and use import-export as well.
Yes.
Yeah.
And third-party software.
Yeah, I was just about to say, if it's not a very large amount of data, there are a lot of open source and freeware clients out there that you can easily use. There's a ton of them on the internet, and they all support Glacier directly or working with both S3 and Glacier. Cloudberry is one of them.
What about CommVault, who has a direct interface into Glacier as well?
Yeah, and if you already use CommVault for your backup, as I mentioned before in my slides, it supports native backup into Glacier. So I think we covered pretty much most of the possibilities on that one.
Ron asked about Aperture, which is the Dell backup product, and qualifications. So.
Yeah, on Aperture, I'm not sure. I don't think it supports it, but I'm pretty sure it'll be supported through the NetApp AltaVault device. But other than that, we'll have to get back to you. Or you can check directly with Dell.
Yeah, put pressure on Dell. Which out of 6 strategies is SODT effective? I'm not sure. Do you guys understand that one?
I'm trying to find it.
Hey, Karthik, we don't understand SODT. If you can ask us again. EC2 to S3.
Yeah, let me take that one. How about backing EC2 instances to S3? Any information on that? So there's 2 options here. One is you can leverage the built-in snapshot functionality that EBS has. So if you use EBS volumes in EC2, you can always take snapshots of those volumes, and then the snapshots automatically protect your data in S3, which means they're highly durable. You can then recover those snapshots back into the same instance or into another instance, even copy them to a different AWS region. The other choice you have is you can run something like a CommVault or NetApp Backup inside EC2 and use that to back up your instances into the supported cloud targets, which are S3, S3 frequent access, and in the case of CommVault, Glacier as well.
Yeah, there is a question, if I want to import my database to RDS database on AWS, do I have the option to specify the destination? Again, migrating a database, we have a preview now for database migration tools, when you install an agent and you can migrate your database into RDS. The question is generic, depends which database. If you're moving from, for example, SQL Server, or from Oracle, you want to move to Aurora. So I suggest check our marketplace. There are many third-party vendors that support that, and also look at our new database migration service that's in preview right now.
I have a question here regarding the gateway. Are there any plans to deploy Storage Gateway into GovCloud? GovCloud is our federal region. So we are still collecting requirements for that. We're going to take your feedback into account. There's nothing I can share at this time specific to that.
So on Karthik's question, which is cost effective? Which of the 6 strategies is the most cost effective? I think it wildly varies.
Yeah, so regarding the question of which strategy is most cost effective, the reason we sort of introduced it in a balanced way is you got to choose the right tool, or sometimes a combination of the tools for the right job. So for example, if you have 10 petabytes that you need to transfer one time, and you're currently using your entire internet connectivity is a gig E, you probably don't want to try and push the 10 petabytes through the gig E, because that's going to take you a year to move over. Instead of that, you can utilize as many snowballs as possible at 50 terabyte increments to move over that very large data set. Of course, the same applies even to a petabyte or much less amounts of data. So that's just one example, but really you just have to use the right tool for the task. Sorry, I can't be more specific than that.
But contact us and we can work with you on an architecture.
Yeah, absolutely. Always contact us, and we'll give you some recommendations specific to your scenario.
The Snowball uploader, can you do that?
Yeah, so there's a question of how I can upload data to Snowball and what protocols used. Essentially how the process works is you load, there's a Snowball client that you need to load on a host in your environment. That client can be loaded on a Windows, Linux, or a Macintosh host, and then it can read from any of those file systems. What the Snowball client does is it converts that data from that file system into an object storage. So you can think of essentially the Snowball as a portable object store. When that data then is copied over, it can be directly imported into S3. There's no authorization necessarily before uploading. It's the client itself, once you've installed it on that host needs to have access either locally to those files, or if you're copying it over from, say, network attached storage, then it just needs to have access to that NAS.
And I'm going to take the question, where was it? Any more details? This is from Gregory. Any more details on Box integration? So Box has a joint solution with AWS where Box basically leverages a service called Cloud HSM, where we deploy on behalf of customers cloud security encryption modules within our regions, within our data centers. And so Box leverages and encrypts all data from your own data center through the Box application using that Cloud HSM to manage the keys securely. So the Cloud HSM manages the keys, and Box then uses those keys to encrypt all data back and forth in a very secure manner. That's the level of integration we have today with Box.
Eric's question about storage vendor compatibility with the software, the storage gateway appliance. I think iSCSI is the answer there.
Was this? Can storage gateway appliance migrate data from any storage vendor that is on-premise to S3? So the answer is yes, because you can use any backup software or really any copy command to copy data from your existing storage appliances into the volumes that the storage gateway provides, and then those volumes would migrate the data and persist it into S3. If you then want to mount it in the cloud, in AWS, you can use a virtual version of our storage gateway and mount that on mount the data on EC2 instances, and then do whatever you wish from that point. Hopefully that makes sense. See if we have any more questions here. I think we have 2 more minutes left, so let's see if there's anything left. Yeah, maybe you can take this, Eric. The last question from Taras: how can I upload data to Snowball? Oh, you already answered that one. Sorry about that.
Joshua has one. So we're looking into one more here, guys. Trying to figure out how to answer it.
Roy, I have a question that you might be able to answer. Do you know if AWS interacts with Delphix, which is a database as a service provider? You familiar with that?
No.
Sorry, yeah, we don't have an answer to that one as well from Sam. Not at this time.
Yeah, there is a question from Joshua about ingest images that are being continuously captured throughout the day and put into a data center. So depends what are the size of the images. If you have a very high compression rate, you can stream them directly to via Kinesis Firehose directly to S3. Or if the images are quite big, you might want to do a daily batch upload into your AWS.
To S3.
To S3, right. Depends how the content and the images are being retrieved. So you might want to use the CDN if you need a high throughput delivery, or you might want to use DynamoDB also to build a metadata tag. Very common use case. You might want to change your architecture, directly load the data into S3 and use a Lambda function as soon as the image is stored in S3. And Lambda function will create a metadata tag, and then it will be able to retrieve the picture very quick and present it.
Thank you, Roy.
So I'd like to extend a special thank you to our presenter Guy for his time and a great presentation. I'd like to extend a special thank you to our presenter Guy for his time and a great presentation, and Mark, Eric, Roy, and Ju for answering the audience questions. So if you have any comments on our previous and upcoming webinars, please feel free to email to aws-webcasts@amazon.com. Thank you to our audience for taking the time to join us today. Enjoy the rest of your day. Thank you.